In order to write a linear equation in slope-intercept form, you need to know two pieces of information: what that slope is, which is used as the coefficient of x, or the m value, and what the y-intercept would be, which is that constant of plus b. So let's say you knew the slope was -3/4 and you knew the y-intercept was -2. To put those together for your linear equation, it would be y equals -3/4 x minus 2. Notice we wrote minus instead of plus since it was a negative. If, on the other hand, you knew that the slope was 4 and your y-intercept was 0, you might be tempted to write y equals 4x plus 0. But a plus 0 at the end doesn't change anything, so that equation would be the proportional example of y equals 4x with no constant at the end. So in this video, we're going to look at what if the slope is 0 or what if it's undefined. And to do that, we're going to revisit an old abbreviation tool that you may be familiar with, and that would be HOI and VUX. So you first learned that HOI helps you remember that these horizontal lines have a slope of 0, which means the equation is y equals a number. To help us remember why that is, we can revisit the concept of slope, which is the change in y over the change in x. We can see that on a horizontal line, your change in y is 0 because it's not moving up or down at all. So here you would have a slope of 0 over a number, which is where your slope of 0 comes from. Looking at that graph, if y is equal to the same number every single time, that equation for this specific example would look like something y equals -8, meaning it's dropping down to -8 and staying there the entire time. By comparison, a vertical line has an undefined slope. And if we look at y, this time your change in x is 0 because it's not moving left or right at all. So your initial slope setup would be some number over 0, which is where that undefined slope comes from. And here, since it's your x value that's not changing, this time your equation would look like something x equals 7, meaning it's over at 7 and not moving off of that. So let's look at how we can get to these if you're given a graph or given a table. So when I'm given a graph that's a horizontal line, immediately my mind goes to a horizontal line has a slope of 0. So if that change in y is 0, therefore your slope is 0, that reminds me of that HOI, meaning a horizontal line, to remind me that that goes with a y equals value. So I would set up my equation as y equals a number, and the number you would use is the y value for the given graph. So we can see here it's up at 7 and not moving from that. So my equation would be y equals 7. By comparison, if I had a table, it might take me longer to get to that point. So you can always start by starting to find your slope. So that slope is that change in y, so as you move down the table, I can see that here my slope isn't changing at all, or my change in y is not changing at all, whereas my change in x is increasing by 5. So when I go to calculate my slope, I see that I have 0 over 5, which is equal to 0. So this is then when my mind goes to, okay, my slope is 0, so that is another HOI equation. So again, setting it up as y equals that number. This time, what number I'm going to put is the y value that's staying consistent in that table. So here, this would be the equation of y equals -4. By comparison, if you ever have an undefined slope, we need to figure out how to write an equation for that. So here on this graph, again, first thing that stands out to me is that is an undefined slope, and that goes with that VUX abbreviation tool. So a vertical line, undefined slope, is my x value. So this equation would look like x equals a number, and again, I'm going to use the x value that it's at and staying at. So here it would be a -5. For a table, and I might not realize that this is a special case when I first look at it, so start by finding your slope. Here my slope is increasing by 4 for my change in y, but my change in x is staying consistent at 0. So when I go to originally set up my slope, I have 4 over 0, which is what tells me this is an undefined slope. So at that moment, that u for undefined is what's going to help me remember VUX, and therefore I'm going to use that x value of wherever it is which is 4 here. So let's look at practicing these. Here for this first graph, I see a vertical line with an undefined slope, so I'm focusing here on my x value. So my x is equal to, and here it's at, -5. For this other example though, I see a horizontal line that has a 0 slope and is associated with a y value staying constant. So here I'm going to set it as y equals and use the number on the graph, which here is 8. For a table, again, it might take me a little longer to realize it because I'm going to start by finding my slope, and maybe you don't need to do that, which is great. Maybe you're recognizing it right away. But here my change in y is increasing by 4 as I move down, but my change in x is 0 because it's staying constant. So my slope would be 4 over 0, which is undefined. That's what's going to help me remember that an undefined slope goes with x. So my equation would be whatever the number is. So here x equals 2. For the other one, again, starting by finding my slope, here my change in y is 0. It's not changing. But my change in x is 3. So if I'm starting by finding my slope, I would have 0 over 3, which is 0. And that's what's going to help me remember that a 0 slope is associated with a y value staying the same. So here my equation would be y equals, and I'm going to use the number from the table. So for given that information, I'm going to show you how you can kind of visualize a graph and help you write the equation for that. A slope of 0 is associated with horizontal lines and therefore a constant y value. If we look at the other horizontal line graph that we have here, we see that the y-intercept is 8. And if you notice in my equation of y equals 8, that y-intercept is also the same y value that's staying consistent throughout. So that means for situations like these where I know the slope is 0 and I have the y-intercept, that y-intercept is going to be the same, whoopsies, as the y value in the equation. So this would be the equation y equals -3. By comparison, if we have an undefined slope, that goes with vertical lines and therefore a constant x value. And if we use this as an example to help us visualize what's happening, a vertical line might not have a y-intercept. If you look, this graph is never crossing this y-axis. So you can see that here it actually says the y-intercept is none. So it has to give you more information. And you can see that here that it gives you a point that graph passes through. So if we think about points, points are listed as an x value and a y value. So for an undefined slope, that's a vertical line with an x value. So I'm going to pull the x value from that point. So this would be the equation x equals 7 coming from that x value.